Hey everybody, sorry it's been a while since I've uploaded a video, but I'm going to do the 1.3 homework problems right now. So I'm going to start with that. We have the first section, the directions say to determine if each equation has one solution, no solution, or infinitely many. Okay, so the first one, challenge 1, is 3k plus 4 equals 12 plus 3k. Now in a multi-step equation, we want to try to get the variables together first. And since they're on opposite sides of the equal sign, we're going to do the opposite operation to move one of them to the other. Well, I'm going to start with this 3k here. And so since it's positive, I need to subtract it. Well, that's 0. And this is 0. Well, that means I'm left with 4 equals 12. Now, the question to ask yourself is this ever possible? Is 4 pennies the exact same thing as 12 pennies? And visually, you can see that they're not. Okay, so that means 4 does not equal 12, and there's no solution. Now, we can check ourselves just to make sure. By checking a no solution equation, you just pick a random number to substitute in for the variable. So I'm going to pick 6. When you're checking, after you substitute in the solution or the number that you're checking with, you just simplify each side. Okay, so the equal sign continues to come down, and we're going to simplify the 18 plus 4, which is 22, and then the 12 plus 18, which is 30. And so, is that a true statement? And the answer is no. So we have just double checked to make sure that our no solution is correct. Okay, so I'm going to do number 2. And I apologize for the delay in the picture. This is an old document camera, so please bear with me. All right, number 2 is 2 times h plus 1 equals 5h minus 7. All right, so we have the distributive property here. Whenever you have a number that is being multiplied by something like a group of something. So this group here is h plus 1, and we can't do anything else with the h plus 1 until we distribute the 2. So when you're distributing, you're multiplying. So 2 times h is 2h, and 2 times 1 is 2. And then you bring down everything else you haven't used yet. And just like in the previous equation, we have variables on either side. So we're going to move one to the other. And I tell my students, if at all possible, try to keep the coefficient of the variable positive. The coefficient is just the number that's being multiplied by the variable, the one that sits right by it. So I'm going to subtract 2h on each side. 5 minus 2 is 3. So that's 3h minus 7. We're still trying to isolate the h, so that's why we add the 7 to both sides. And we're getting closer and closer to get h all alone. And after you divide by 3, 3 equals h. Now, since we have just one answer for this equation, you have your variable equal to one number, you're going to take the 3 and substitute that back into the original equation. Always check in the original equation. Always check in the original. So the original is the 2 times the h plus 1, and since we think that h is 3, I'm putting 3 where the h is, equals 5 times the 3, which is h, minus 7. Now, if you have the 2 times this group here, but we can simplify 3 plus 1, and so we're going to do that first. So 3 plus 1 is 4. According to order of operations, we have to multiply before we can subtract. So that's 15 minus 7. So 2 times 4 is 8, and 15 minus 7 is 8. And we are correct because 8 does equal 8, and it always will. This is true. All right, number 3. We have 3 times, we do number 3. 3 times 4g plus 6 equals 2 times 6g plus 9. So we have these expressions grouped here. The 4g plus 6 is in a group, and the 6g plus 9 is in a group. Now we cannot simplify this here because we have no idea what g is, and so therefore we cannot add that to a whole number. Okay? So that's why we have to distribute first. So 3 times 4g is 12g. 3 times 6 is 18. 2 times 6g is 12g. And 2 times 9 is 18. So if you notice, you have the same expressions on either side of the equal sign. So that should kind of clue you that you will have infinitely many solutions. I like to go ahead and get the variables together before I decide anything. So if I subtract this 12g from both sides, those are 0, and we're left with 18 equals 18. Now this is true. In number 1, we had, at the end of solving, we had 4 equals 12, and that was not true. If you solve an equation where your final line here is true, then that means you have infinitely many solutions. That means you could take any real number in the entire world and substitute it in for g, and you're going to get a true statement here. So let's test that theory. So I'm going to say that g is negative 10. Is that's the random number I have chosen. So negative 40 plus 6 will be negative 34. Negative 60 plus 9 is negative 51. 3 times negative 34 is negative 102. And 2 times negative 51 is negative 102. So we ended up with a true statement again. And so that's why we have infinitely many solutions. All right. Okay, 4, 5, and 6, you were just asked to solve the equation for the variable. And so you didn't have to state whether there was one solution, no solution, or infinitely many. So we're just going to solve them and check them. All right, number 4. $60. 15. Yes, 60. Okay, so we have a negative 9W and a positive 4W. Can you guess which one we will move to the opposite side to keep our coefficient positive? We will add the 9 because 4W plus 9W is 13W. And 78 divided by 13 is 6. And we have to check it. Negative 9. Yes. Sorry. I had to use my calculator. I had a moment there. All right, so that's true. So we know that 6 is our correct solution. Okay, 5. We have 2/3 times 3x plus 9 equals negative 2 times 2x plus 6. Now, my students always freak out when they see a fraction, but they're not as bad as you think, because when you're multiplying a fraction by a whole number or another fraction, it is very simple to do. Now, adding and subtracting fractions, yes, that is harder, but here we're multiplying, to begin with. So, let me do a little sidebar over here. So we have 2/3, okay, and we're multiplying it by 3. 3 is a whole number, but I can make 3 a fraction by placing it over 1. Any whole number or fraction can be put over 1. What did I say? I'm sorry. Any whole number or integer, can be placed over 1 to make it a fraction. So the way that you multiply two fractions is you multiply the top, and you multiply the bottom. 6 divided by 3 is 2. So And the way I look at it, I say, well, 2 times 3 is 6, divided by 3 is 2. Now here, let's do it again. So we have 2/3 times 9 over 1. 2 times 9 is 18. And 3 times 1 is 3. 18 divided by 3 is 6. So we want to try to keep our variable term positive, you know, that coefficient. So I'm going to add 4x. Oh, sorry. Alright, so 2/3 times the negative 9 plus 9 equals negative 2 times negative 6 plus 6. Well, negative 9 plus 9 is 0. Negative 6 plus 6 is 0. And, excuse me, anything times 0 is 0. But 0 still equals 0, so we know that x is negative 3 is the correct solution. All right, there's 6. 2 times 4a plus 2 equals 4a minus 12 times a minus 1. We have the distributive property. So 2 times 4a is 8a plus 4 equals 4a minus 12a plus 12. Now if you notice, we have like terms on the same side. You know, here is our equal sign, and I've done this before. If you draw this down the middle, that creates your left side and your right side. Okay? So the 4a and the negative 12a are on the same side together. That means we're just going to do the operation that's in between them. So 4a minus 12a is negative 8a. Okay, again, if you have variables that are on the same side of the equation together, you just combine them with the operation that they originally have. Okay, now we have variables on the opposite side. So I do the inverse operation to move the negative 8a. Okay. 8a plus 8a is 16a. And then if you subtract 4, a equals 1/2. I tell my students, always try to keep your answer in fraction form, because sometimes you might get decimals that repeat, and if you write that decimal as a decimal in your problem, then that doesn't represent the entire value of that number. Like if you have 1/3, which is 0.3 repeating, well, that 3 repeats on and on forever. So instead of putting 0.33 back into a problem, you would need to put 1/3. Now 1/2, you know, we know that's 0.5, but we need to get in the habit of using fractions to substitute back in. Four times 1/2 is 2. Oops, 2 minus 12. So 1/2 minus 1 is negative 1/2. Negative 12 times negative 1/2, you're taking half of 12, and multiplying a negative by a negative makes it a positive. And we have a true statement, so we know that 1/2 is correct. Alright, let's go to challenge 7. 7 is talking about internet providers. I'll show you the picture. So, down here. You have local internet providers, Comcast versus AT&T. So if you have Comcast, you'll have an installation fee of $40, and the price per month for this specific package that has been described for you is $60.65. If you go with AT&T, you get $50 a month, or I'm sorry, you pay an installation fee of $50, and you pay $64.95 a month for this package here. Now, if you notice, you have some different information there about each internet provider. These two statements were just informational, that you will not use those numbers in your equation. The challenge 7 says write an equation to represent the month at which CC and Gracie will pay the same total amount for their internet service. So if they're wanting us to know at what month they'll pay the same amount, well, same means equal. Okay, same is equal. Now, CC went with AT&T, and Gracie went with Comcast. Now, CC's AT&T package is a $50 installation fee. Now, we have to think, are we going to pay an installation fee every month, or are we going to pay that fee just one time? The price we pay monthly will be the $64.95. And what would we need to multiply by that price to show to show which month they would be paying the same? So we don't know which month, so X will represent number of months. And then over here, we're going to set up the problem the exact same way. We have $60 and, 65 cents times the number of months, because this is what you pay monthly, and then plus the 40. Okay, now let's solve. Oh, sorry, I keep doing 9 right there. It's a 6. That would be 4.3. believe it's 2.3. Yeah, around negative 2.3. Well, we need to ask ourselves, does that make sense? Are they going to be paying the same amount at negative 2.3 months? And, you know, most of the time students will say, no, you can't have negative number of months. So what does that mean in terms of solving this problem? That means that there is no answer, or that they will never pay the same amount of money at the same month. Okay? Now 8 was just a question that was asking the students, like, which service do you think is a better deal and why? Most everybody said that the Comcast, because the prices were cheaper, but you have to look at what you're offered in terms of speed. Like, this is 25 megabytes per second with 300 gigabyte data limit, and then the AT&T is 45 megabytes per second with the 250 gigabyte data limit. And so I wanted them to kind of use that to see which one would be a better deal. So that was more of an opinion type problem. Okay, number 9. We're almost through. Number 9. We are given a problem that has been worked, and I'll just show it to you. Okay, and we need to describe and correct the error in solving the equation. So what I always tell my students, you solve it yourself first, and then you look for the mistake. Now they went ahead and brought it all the way down to 0 equals 0, which you can do that, but I feel like that makes more sense. Well, there really wasn't an error in solving, but they did say that this equation has no solution. So that is the mistake, because it has infinitely many solutions. All right. Challenge 10 was ordering numbers from least to greatest. So I have 9, and then the absolute value of -4, -4, 5, and then the absolute value of 2. Now first you have to find the absolute value of the numbers that are in the absolute value bars. So the absolute value of -4 is actually 4, and the absolute value of 2 is 2. So let's order these from least to greatest. So the least number will be -4. Then we have 2. I'm sorry, absolute value of 2. Excuse me. So we use -4, absolute value of 2, and then absolute value of -4, 5, and then 9. All right. Number 11, we're doing the same thing. We have -18, absolute value of -24, -19, absolute value of -18, and then absolute value of 22. So the least number would be -19, and then we have -18, And then we have the absolute value of negative 18, which is positive 18. Then we have the absolute value of 22, which would be 22. And then the absolute value of negative 24, which is 24. Okay? Okay, one more problem. Okay, so challenge 12, 13, and 14, this is for one particular problem. So we have a chart that tells us the students enrolled in Spanish and French at Oak Grove High. And so this is the chart that we have. It looks something like this. So we have Spanish, French, students enrolled this year for Spanish was 355 and for French was 229. And then the average rate of change, average rate of change for Spanish is 9 fewer students each year, and for French is 12 more students each year. Okay, so then we have a graph I'm about to show you. Okay, so the x-axis is years from now, so that's your time. And then the y-axis is the number of students enrolled. All right, so we have, you see French is this line. And Spanish, excuse me, is that one. All right, so the first question is to use the graph to determine after how many years there will be an equal enrollment in Spanish and French. And so what the students had to find was, you know, when those lines intersect, well, the classes both have 300 students, and that's at 6 years. The next question is, how does the equation 355 minus 9x equals 229 plus 12x relate to the graph and the table? So if you notice, the students enrolled are here. So we have 355 students enrolled in Spanish. And then this represents the average rate of change, 9 fewer students each year, because our unknown was years from now. Here we have French enrollment, 229, plus the average rate of change, the 12 more students each year. So the table, the graph, and this equation all say the exact same thing. I think that's so cool because it's just a different representation of the same thing. And then the last one is, can you use this equation to determine whether your answer in challenge number 12 is reasonable? So our answer in 12 was 6 years. So we're going to substitute that in with this equation that we have. All right, 355 minus 54 is 301. And 229 plus 72 is 301. So our initial answer of 6 years from now, French and Spanish will have the same number of students enrolled is correct. And that is it for homework 1.3. Thank you.